The appropriate solution to the problem of using portable generators with transfer switches in homes is to use a transfer switch that does not switch the neutral conductor. This eliminates the risk of a double-bonded neutral and ensures current flows properly through the intended paths. It is important to not alter the portable generator to remove the neutral to frame bond. This is a safety hazard for 120 volts receptacles. Instead, connect the generator to the transfer switch using a 4-wire, 240 volts cord. Connect the ungrounded conductors and omit the grounded neutral conductor. When the transfer switch is activated, the ungrounded conductors from the generator are connected to the ungrounded conductors of the house wiring system. Current flows from the generator to the house wiring system and returns through the ungrounded conductors of the cord. The grounded neutral conductor in the house wiring system remains connected to the grounding electrode system of the house, providing a path for fault currents. This solution meets the requirements of NEC 702.10b, which allows for the use of a neutral floating generator with transfer equipment that does not switch the grounded conductor. It also complies with NEC 250 as it ensures that the grounded neutral conductor is bonded only at the main service panel and not at the generator. Some generators may require a jumper to connect the generator case to the neutral terminal to create the neutral to frame bond. Remove this jumper when using the generator with a neutral floating transfer switch. Always follow the manufacturer's instructions for the safe operation of the generator and transfer switch. The NEC, or National Electrical Code, provides comprehensive standards for electrical safety. Understanding and adhering to these standards is crucial when dealing with generators and transfer switches, especially in residential settings. Firstly, NEC 702.10 addresses optional standby systems, which include generators used for providing power during outages. It mandates specific configurations to ensure safety and prevent issues like circulating ground currents. Secondly, the code offers two main options for connecting a generator. Option A involves transfer equipment that switches the grounded neutral conductor and a generator with its grounded neutral conductor bonded to the case. Option B, the preferred method in this scenario, uses transfer equipment that does not switch the grounded neutral conductor and a generator with its grounded neutral conductor not bonded to the case, also known as a neutral floating generator. Using a neutral bonded generator with transfer equipment that does not switch the neutral creates a double bonded neutral situation, where the neutral is bonded to ground at both the generator and the main service panel. This is a code violation and creates a potential safety hazard, as it allows current to flow through the grounding conductor. The grounding conductor is designed to carry fault current, not normal operating current. Current flowing through the grounding conductor can cause electromagnetic interference and potentially energize metallic parts of the electrical system, creating a shock hazard. Modifying a portable generator to remove the neutral to frame bond might seem like a solution, but it creates another safety issue. If the generator is then used to power a cord and plug connected equipment via its 120 volts receptacles, the equipment will not have a proper ground reference, which can be dangerous. Additionally, altering the generator might void its warranty and violate safety certifications. Omission of the grounded neutral conductor between the generator and the transfer switch is a safe and code-compliant solution if done correctly. It effectively creates a 2-pole, 3-wire 240 volts connection between the generator and the transfer switch. The 120 volt circuits in the house will still function correctly, as their neutral current will return through the unswitched grounded neutral conductor to the main panel. Using a 4-wire cord with separate ground and neutral conductors is essential. The ground conductor provides a safety path for fault currents, while the neutral conductor carries the normal and balanced current from the 120 volt circuits. The transfer switch plays a critical role in safely connecting the generator to the house wiring. It isolates the house wiring from the utility grid, preventing backfeed, which can be dangerous to utility workers and damage equipment. The transfer switch should be properly rated for the voltage and current of the generator and the house wiring. Manual transfer switches are commonly used in residential applications. These switches require manual operation to switch between utility power and generator power. Automatic transfer switches are also available, which automatically switch to generator power when utility power is lost. When connecting a generator, always follow the manufacturer's instructions carefully. Ensure that the generator is properly grounded and that all connections are tight and secure. Never overload the generator, as this can damage the generator and create a fire hazard. Test the generator and transfer switch regularly to ensure that they are functioning properly. Replace any damaged or worn components immediately. Consider hiring a qualified electrician to install the transfer switch and connect the generator. An electrician can ensure that the installation is safe and code compliant. They can also provide guidance on the proper operation and maintenance of the generator and transfer switch. Regular maintenance is essential for ensuring the reliable operation of the generator. This includes changing the oil, cleaning the air filter, and checking the spark plugs. Store the generator in a dry and well-ventilated area. Protect it from the elements to prevent corrosion and damage. Always disconnect the generator from the transfer switch before performing any maintenance. Carbon monoxide poisoning is a serious hazard associated with generators. Never operate a generator indoors or in an enclosed space. Ensure that the generator is located in a well-ventilated area away from windows, doors, and vents. Install carbon monoxide detectors in your home to provide an early warning of carbon monoxide buildup. If you experience any symptoms of carbon monoxide poisoning, such as headache, dizziness, nausea, or shortness of breath, seek medical attention immediately. Electricity can be dangerous if not handled properly. Always follow safe electrical practices when working with generators and transfer switches. If you are unsure about any aspect of the installation or operation of the generator and transfer switch, consult a qualified electrician. Proper planning and preparation are essential for ensuring a safe and reliable backup power system. This includes selecting the right generator and transfer switch, installing them correctly, and maintaining them properly. Understanding the NEC requirements for optional standby systems is crucial for ensuring electrical safety. Adhering to these requirements can prevent code violations and potential hazards. Using a neutral floating generator with a transfer switch that does not switch the neutral is the recommended solution for most residential applications. This configuration eliminates the risk of a double-bonded neutral and ensures that current flows properly through the intended paths. Always prioritize safety when working with electricity. If you have any doubts or concerns, consult a qualified electrician. Staying informed and following best practices can help you to safely and reliably power your home during an outage. The information provided is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician to ensure that your electrical system is safe and code compliant. The NEC is updated regularly, so it is important to stay informed of the latest changes. You can purchase a copy of the NEC from the National Fire Protection Association or NFPA. You can also find information about the NEC on the NFPA website. Local electrical codes may also apply, so it is important to check with your local authorities. Following these guidelines will help you to safely and reliably use a portable generator with a transfer switch to power your home during an outage. Remember, safety should always be your top priority. In summary, when installing a generator with a transfer switch, prioritize safety and code compliance. Firstly, use a transfer switch that does not switch the neutral conductor. Secondly, maintain the neutral to frame bond on the generator for safe operation with 120 volts receptacles. Thirdly, connect the generator to the transfer switch with a 4-wire 240 volts cord, omitting the neutral connection. Fourthly, ensure the house neutral is properly grounded at the main service panel. Fifthly, follow all manufacturer's instructions and local electrical codes. Sixthly, regularly inspect and maintain the generator and transfer switch. Seventhly, use carbon monoxide detectors and operate the generator in a well-ventilated area. Eighthly, if unsure, consult a qualified electrician. Ninthly, never overload the generator. Tenthly, always disconnect the generator before performing maintenance. By adhering to these principles, homeowners can safely and effectively utilize portable generators for backup power.